Good morning, children. We'll continue the class now. That's for 7th standard science, unit 3, matter around us. So in the previous class, what did we see, children? We saw about the atoms, molecules and elements. And elements we saw about the metals and non-metals. Now we'll continue with the metalloids. So next is the metalloids, children. So what is metalloids? That is exhibit the properties of both metals and non-metals. For example, silicon, arsenic, antimony and boron are some of the examples of the metalloid. That is the properties of both metals and non-metals. So what did I say about both metals and non-metals properties? That the metals are hard and shiny, non-metals are soft. So these combine. Okay, these properties of both metals and non-metals are called as a metalloid. That exhibits the properties of both metals and non-metals. Metals and non-metals is called as metalloids. Did you understand, children, what is metalloids now? That has the properties of both metals and non-metals. Both they are called as metalloids. Now next we will see the differences between metals and non-metals. So what's the difference between the metals and non-metals? Metals and non-metals. Now what are the differences now we'll see. So the first one is metals are lustrous. They have a shiny surface. That is, they are very hard and shiny. That is lustrous and shiny. So metals are lustrous and shiny. So when compared to non-metals, non-metals are non-lustrous and non-shiny. So metals are lustrous and shiny, while the non-metals are non-lustrous and non-shiny. Okay, children? So now the next one is metals are generally hard. So already I told you they are hard, while the non-metals are the soft. So metals are hard, non-metals are soft. Okay? So the next is most metals can be bent, beaten into sheets, and they can be drawn into wires. So already I said about the metals and non-metals. Yeah. So now they have given the differences. When we go to non-metals, they cannot be bent or beaten into sheets and they cannot be drawn into wires. So most metals can be bent, beaten into sheets and drawn into wires. Drawn into wires. Okay, children? And then that is non-metal is cannot be bent, then beaten into sheets and cannot be drawn into wires. Cannot be drawn into wires. Okay, children? Now, next is most metals are good conductors of electricity. So, if you see the non-metals, they are poor conductors, that is bad conductors of electricity. So, they are good conductors of electricity and they are bad conductors of electricity. Bad conductors of electricity. So next if you see, most metals are good conductors of heat and non-metals are bad conductors of heat. Good conductors of heat and bad conductors of heat. Okay, non-metals are bad conductors of heat. Next, most metals make a ringing sound with strokes. So metals, when we make sound, what happens? A ringing sound comes from the metals. But when in the non-metals, you cannot find that ringing sound. That is, that does not make any sound. So most metals make ringing sound. Non-metals does not make any sound. Does not make any sound. Okay, so these are the differences, children. We are going to see the metals and non-metals. That is, they are lustrous and shiny. The non-metals, non-lustrous and non-shiny. Then they are hard, non-metals are soft. Then metals can be bent, beaten into sheets and can be drawn into wires. Well, the non-metals cannot be bent nor beaten into sheets and they cannot be drawn into wires. Then the metals are the good conductors of electricity and the heat, while the non-metals are bad conductor of electricity as well as the heat. Then metals make the ringing sound while the non-metals does not make any sound. So these are the differences between the metals and the non-metals. Now next we are going to see the symbol of an element. So next is the symbol of an element, children. Symbol of an element. So after the differences, we are going to see the symbols of an element now. So for example, a symbol. So what is a symbol we are going to see? A symbol is an abbreviation or the short form or the representation of a chemical element. So it's a symbol means a short form. Short na abbreviation. So it's a short form or the representation of a chemical element. And there's a unique symbol. That's a different symbol of each element. It represents one atom of the element and derived from the name of the element, which either be in English or the Latin. And these words are accepted by the IUPAC. IUPAC is nothing but the International Union of Pure and Applied Chemistry. So what is IUPAC, children? International Union Pure and Applied Chemistry, IUPAC. Now, Dalton was the first scientist to use the symbols for elements in very specific sense. So Dalton was the first scientist to use the symbol for the elements. So who was the first scientist? Dalton. Who was the first scientist, student? Dalton was the first scientist to use the symbols for the elements. And Berzelius suggested that the symbols of elements can be written in one or two letters of the name of the element. It can be written in one letter or two letters you can use. Then see children here, in the beginning the name of the elements were derived from the name of the place where they were found for the first time. So on the Kaathala in the ancient times, what they did, they gave the name of an element by the place name. That is, for example, the name copper was taken from Cyprus. Cyprus is a place and it was given, there they introduced that copper there, so gave the name as a sea. Okay, that is for Cyprus. Then some names are taken from the colors. For example, gold. So what is the color of the gold? Yellow. Yeah, so gold was taken from the English word meaning yellow. So by the place name or by the color name they are taken. So nowadays, now what they are using? They are not using the place name or the color name, but nowadays IUPAC approves names of first one or two letters of the element's name in English. So they are taking what they are taking, first or the second letter of the element in the English, and the first letter of a symbol is always written in a capital letter and the second letter as a small letter. For example, if you take can take calcium. If you take calcium, so calcium is this, and if you take symbol, so that the first letter is capital and the small letter is a small letter. Do you understand, children? So calcium means, so it's an element. So what they are giving the symbol as Ca. Okay, they are given as a Ca, and for that C written in the capital letter and the A in a small letter. Okay, children. So IUPAC approves the name by giving the first two letters of an element, and the first letter should be in a capital letter and the second letter should be in a small letter. So do you understand, children? And here the following rules are followed while assigning symbol to an element. That is, chemical symbol usually consists of one or two letters like this. Okay, it consists of one or two letters. And the symbol of most elements correspond to the first letter of their English name. That is the capital letter. Then, for example, another example they are given. For example, oxygen O, hydrogen H. It's a capital letters given. Okay, if the small second letter is only if it is there, means it should be written in a small letter. If one letter is there, everything should be in a capital letter. That is for oxygen O and hydrogen H. Do you understand, children? Now, find out the symbols of the elements. They are given that in activity 1. So we are going to do that now. So those who have the book, take down in your book, children, use a pencil and write in your book. That is in the page number 33, activity 1. Elements they have given, we have to write the symbol. Elements and symbol. That is first one, gold. So what is the symbol of gold? AU. Okay. Then next, silver. For silver, AG, that is first letter is the capital letter and the second letter is a small letter we are using. Next is a copper. Take down in your book, children, and so those who don't have, you can take down in your rough notebook. Then iron. For iron, Fe. So next, nitrogen. It's only one letter, N, that is the capital. Then oxygen, O. Then aluminium, Al. Then next is a calcium, Ca. Then phosphorus, P. Magnesium, Mg. Okay. The next is a potassium, K. Sodium, Na. Okay, children. So these are the symbols, that is gold, Au, silver, Ag, copper, Cu, iron, Fe, nitrogen, N, oxygen, O, aluminium, Al, calcium, Ca, phosphorus, P, magnesium, Mg, potassium, K, and sodium, Na. So these are the symbols of the elements. Now we'll see the elements in the human body. So we are going to see the elements in the human body. Now nearly 99% of the mass of a human body consists of 6 chemical elements. So how many elements, children? 6 chemical elements in a human body. That is oxygen, carbon, hydrogen, nitrogen, calcium and phosphorus. Another 5 elements make up most of the least percentage. That is they are potassium, sulfur, sodium, chlorine and magnesium. So first we'll see the 6 chemical elements that is in a human body, children. Just 6 are there. That is oxygen, carbon, hydrogen, nitrogen and calcium and phosphorus. These are the 6 elements. And the other 5 elements that is on the least, romba kammiyana percentage irukkuradhu vandu potassium, sulfur, sodium, chlorine and magnesium. Now, elements in the air. Next we are going to see the elements in air. Now, air is a mixture of gases. Air is a mixture of gases. The molecules of 2 different elements, that is nitrogen and oxygen, make up about 99% of the air. That is nitrogen, that is elements in the air, children. In that, nitrogen and oxygen make up about 99% of the air. How much, children? 99% of the air. The rest includes, that is 1% is the rest. The rest includes small amounts of argon and carbon dioxide. So rest is the argon and carbon dioxide, that is CO2. Okay. So how much is 99% of the air, children? That is nitrogen and the oxygen. And the less amount, that is rest is argon and carbon dioxide. Now other gases such as neon, helium and methane are present in trace in a romba chinnada amount. Okay, trace amounts. And oxygen is a life-giving element in the air. So oxygen is a life-giving element, that is without oxygen there is no air. Okay, oxygen is a life-giving element in the air. Do you understand, children? Make it noted that oxygen is a life-giving element. So till here we have finished the elements, children. So next we are going to go to the compounds. So we have finished the elements and we have we've seen the symbol also. So next we are going to go to the compounds. What is that next? Compounds. So in the compounds, a compound is a pure substance that is formed when the atoms of two or more elements combine in definite proportion. So what's a compound? A pure substance. A compound is a pure substance formed when two or more elements combine in definite proportion. Chemically in definite proportion. So what is that, children? A pure substance formed when two or more elements combine in a definite proportion. The compounds exhibit properties that are entirely different from the properties of elements. So compounds are the different from the elements. Okay, the properties of compounds are different from the properties of the elements now. For example, the atoms of the elements, that is hydrogen and oxygen, combine in a fixed ratio to form the compound water, that is H2O. That is hydrogen and the oxygen, they combine in a fixed ratio to form a compound water. However, water does not have the same properties of hydrogen and oxygen. So water does not have the same properties of hydrogen and oxygen. So for example, at room temperature, water exists as a liquid while hydrogen and oxygen exist as a gas. Okay, do you understand now, children? So water exists as a liquid at room temperature, while hydrogen and oxygen are the gases, that is H2O. Then also oxygen supports fire, whereas water is used as a fire extinguisher. So oxygen supports the fire, while the water is a fire extinguisher. Fire extinguisher. Okay, children? So oxygen supports fire while the water is used as a fire extinguisher. Now similarly, common salt, already I said common salt is nothing but the sodium and the chlorine, that is sodium chloride. That is common salt is otherwise called as a sodium. So it's common salt, what I said, which we use in the food. And for this, what is here? Sodium chloride. They are called as a sodium chloride is nothing but the common salt which we use in the food. Is a compound made up of elements sodium and chlorine. So what are the two elements here used here? Sodium and the chlorine. And it is used in our food. As already I said, it is used in our food. Whereas sodium and chlorine are poisonous and both are unsafe and consumption. So tani edukkum bodhu it is poisonous as well as unsafe for consumption. Consumption intake panna, that is we are eating. So similarly, common salt is a compound made up of elements mean one or two atoms combined here, two atoms made up of elements sodium and the chlorine. So it is, that is sodium chloride, and it is used in our food. Whereas if you take sodium and chlorine, it is poisonous as well as unsafe for the consumption. So do you understand now, children? So next we will see the properties of compounds. So what are the properties of compounds? A compound is formed only when the constituent elements combine in a fixed proportion. So a compound is formed when the elements combine in a fixed proportion. They have to combine in a fixed proportion. Then next is the properties of compound are different from those of the constituent elements. That is, different from the elements. That is, the properties of compound are different from the properties of the elements. Okay, that is constituent elements. Then a compound cannot be broken down by physical methods. This is because a compound is made up of different elements. Many elements are there, so it cannot be broken physically. That is, physically na nama kaiyala illaya. So the compound cannot be broken down by physical methods. This is because of a compound made up of many elements. So what are the properties, children? A compound is formed only when the constituent elements combine in a fixed proportion. And the properties of compound are different from the properties of the constituent elements. And these compounds cannot be broken down physically because they are made up of different elements. So do you understand now, children, what are the properties of elements? So what did we see now in this class? That is, About the metals and non-metals differentiation we saw. Then metalloids we have seen. Then symbol of an element. So symbol I told you how should we use. That is the first letter is a capital and the second letter is a small letter. We were learning about that. Then the rules also we learned. Then elements of the human body we learned. That is 99% of it is of mass in a human body, and there are 6 chemical elements and 5 least percentage of elements are there. And the elements in the air we saw, that is air is a mixture of gases, and there are about nitrogen and oxygen 90% in the air, and some of the gases are trace amounts. Then next we saw the compounds, and in the compounds what did I say? It's a pure substance with a made up of 2 or more elements combined in a definite proportion, and its compound oxygen is a fire, whereas the water is used as a fire extinguisher. And sodium chloride, that is common salt, we read about this now, it can be used in our food, but if we take sodium and potassium, it's a poisonous and unsafe for the consumption. And next we saw the properties of compounds, student. So in the next class we learn about the chemical formulae and the atomicity, student. Thank you.